So up until now, we have been talking about movements about origin or movements about a specific point. Now, then you can also find out movements about mean. And they are telling you something very important. They are telling you about the shape of the probability distribution or the shape of the frequency distribution, right? So let me just have a look at that. And right. So movement, they tell about the shape of the distribution of random variable, right? So basically the graph of its probability distribution or probability density, the shape of the graph of its probability distribution or probability density. So when you wrote about the movements about origin or movements about a specific point, then you said that what was the movement about the origin? That was summation of fx xi minus 0 or x minus 0, right? That's what you said. But if it is about the specific point, then it is going to be xi minus a, like this. And if you talk about the rth movement about the specific point a, it is going to be like this, summed over x. The only thing is that now instead of a, you have x bar. Now instead of a, you have x bar, like this. And you call this is the rth movement around the mean. Rth movement around the mean, where fx is the probability distribution, right? So let me just write that. The rth movement about the mean of a random variable x is the expected value of x minus x bar to the power r, or x bar is nothing but just mu, right? Or the expected value of x minus mu to the power r, because that is the rth movement. And symbolically, this is the way you write it, right? This is the way you write it. Okay, and this is when you have the discrete case. For the continuous case, right, you write it like fx, your x minus x bar to the power r dx, right? Or x minus mu to the power r dx, whichever way you want to write. Power r dx, right? We'll be just proving the certain properties of movements around these means. So mu naught, we will be proving that this is going to be equal to 1. Mu 1 is going to be equal to 0, right? For any random variable for which mu is existing, right? And then you also have mu 2, right? Then you also have mu 2. And this is of very special importance, right? Because this is telling me about the variance. So it is indicative of the spread of the distribution around the mean. So mu 2 is indicative of the spread or dispersion of the distribution of a random variable, right? And this is nothing but the variance of x. This is nothing but the variance of x, right? So supposedly I have one distribution like this. Let me just draw this. So this also has the same mean, x bar, right? Or I can also have the distribution like this. This also has the same mean x bar, but they're very different distributions. Let's say I have the distribution like this. This also has the same mean x bar, but this is a very different distribution, right? So this is what the mean is going to, sorry, this is what the variance is going to tell me. The spread of the distribution around the mean. Although the mean is same for all the distributions, but they're different. The dispersion around the mean is different. And this is telling me about something which is called skewness of the distribution. But I'll talk about skewness in the another recording. Abhi ke liye, we will just focus on the first two movements of around the mean, which is mu1 and mu2, right? And let us now prove some properties of the central movements. These are also called the central movements. So we have been talking about movements about origin and movements about any point, movements about mean since last few recordings. Now let us talk about a few more properties of movements. So let me just first of all define the movement about any point and movement about mean first of all. So suppose R be any non-negative integer. So definition is the rth movement about any point A has been defined as, or is defined as, mu r dash A, or simply mu r dash as 1 upon n summation xi minus A, summation xi minus A into this guy. Summation, you can also write summation fi into xi minus A. Right, to the power r, where n is nothing but equal to summation fi, a frequency. The rth movement about mean x bar about mean X bar is defined as mu r. So there is no dash here. 1 upon n summation fi xi minus x bar to the power r. N is nothing but summation of fi. Right. Now let us look at the first one. Show that mu naught is 1, mu 1 is 0, and mu 2 is sigma square. These are movements around mean, right? Well, we have mu naught as 1 upon n summation of xi minus this thing, because you are finding out around this point 0. So it is going to be movement about mean when r is equal to 0. So it is going to be like this, which is going to be so anything to the power 0 is 1 upon n summation fi, because anything to the power 0 is 1. So this guy is going to be equal to 1. Mu 1. Right. So first movement about mean, summation of xi minus x bar to the power 1. So it is 1 upon, this is summation of xi, fi minus x bar summation of fi. We can write it like this. But beta, what is summation of fi xi upon n? That is nothing but x bar, right? That guy is nothing but x bar. Summation of xi upon n. Beta, summation of xi upon n is nothing but x bar minus x bar into summation of fi is n, and n upon n has been cancelled out, and so this is just 0, right? Mu 2 is 1 upon n summation of xi. It is also movement about mean, that is second movement about mean, right? This is nothing but variance. It's just the formula for variance, nothing else. Variance. It's just the formula for variance, right? So that is your first property. This guy is your first property. The second property is show that the movements about mean are independent of origin, but not of scale, right? Property 2. Show that movements about mean are independent of origin, but not of scale. So we have so let me write the rth movement about mean. Right. And say I define u as the new variable, x minus a upon h, x minus a upon h. So when I add or subtract anything, it is like the change of origin, right? And when I am dividing or multiplying this is the change of scale, right? Okay. So how do we say this? So you can write what? You can find out what x is going to be. So it is UH equals to X minus A plus HU, right? X bar is, these are constant beta. So when you take the expectation here, expectation of a constant is a constant, and expectation of E of HU, H will come out of the expectations. It will be HU bar, right? So I can subtract, this is, let's say 1, this is, let's say 2. I can subtract 2 from 1. So that is X minus X bar is equal to H of U minus U bar, right? H of U minus U bar. So in place of X minus X bar, I can substitute this. So let's say this is what my star expression is. Substitute in star expression, and you'll be getting mu r as 1 upon n summation of fi, right? In place of xi minus x bar, you can write h u minus u bar to the power r, u minus u bar to the power r, right? Okay, so I can write this as what? H to the power r, 1 upon n summation of fi ui minus u bar to the power r. So there is no a here. So mu r could be written as h to the power r mu u. Now there is no a here. So it is independent of origin, but there is still h. So this is not independent of scale. This shows that mu r is independent of origin A, but not of scale, right? So these are the two properties of movements around mean and origin, whatever. We'll do one more property and we'll do questions based on that in the next class.